and you guys all did this. At least I hope you all did this. I recognized that teams actually said that 11 out of 20 submitted this answer or submitted the assignment. But then when I went to look, for instance, yours, Lida, when I opened yours up, it was there. Even though it said it wasn't submitted, it was there. So I don't know why, but I have not looked at everyone's. I'm hoping that everyone submitted this. But here we go. So let me try to blow up my screen a little bit so I have this. There. In the first question, they've given us a table. The table represents values for the derivative of some function f. This is f prime, right? Got to recognize that right off the bat. They tell us that the function is increasing, which is an important piece of information for one of these problems, and that it's f is twice differentiable. In other words, there's a second derivative that exists. So there's no spot where we have to worry about, you know, a cusp or an asymptote or something like that, or a break in the graph. My dog is whining over here. And then another key piece of information, they told us that at 0, f, so the antiderivative of this table, f is 3. So first question here actually refers back to a concept that we had to discuss in one of the free response questions in the first set of FRQs that I assigned for what was technically test 7 for us. They have given us information about f prime. That's all we have. And they want us to analyze the mean value theorem for f prime, which means we reinterpret the mean value theorem in this way. You're used to seeing it. I'm going to erase some of this. You're used to seeing it like this. F prime of C equals f of B minus f of A over B minus A. Well, for this problem, we're using f double prime is equal to f prime of B minus f prime of A over B minus A. We have gone one step down the line and applied the mean value theorem here for the second derivative as it relates to the first derivative, rather than the first derivative as it relates to the function f. Questions on that at all?
Why can you do that?
What do you mean, why?
Why can you
why am I allowed to apply that?
Why can you just like have another derivative?
So what the mean value theorem says in theory is that if I have a function and I take any 2 points along the curve and connect the dots, the slope of that line, right? The slope of that line is f of B minus f of A over B minus A, right?
Oh.
And what it's saying is there has to be a place, we'll call it C. This is A, this is B, right? On the x-axis. There has to be a place, we'll say C, where the derivative is equal to the slope of the secant line, where I can draw a tangent line. That one didn't work. Where I can draw a tangent line that is parallel to the secant line. Let me zoom in a little bit. All right. So here I've tried to illustrate this would be the tangent line, and its slope is parallel to this slope, the secant line slope. Okay. And that, of course, that x value is C.
Yeah.
So now if I say that that red curve is f prime instead of f, the red curve is f prime, then the slope on f prime, the secant line slope on f prime, this slope would be this, right?
Yeah.
And then the tangent line slope to this f prime would be this slope.
Yeah.
So it applies just absolutely just a direct application. Same concept, just working with a different set of curves. Does that make sense?
Yeah, that makes sense now.
Okay. So again, it's a little tricky because we learn and we discuss the mean value theorem with f prime of C and then f of B and f of A, not f double prime, f prime, f prime. This is where concept really comes in. So now you, because I've explained it here, now you fully understand the concept of this. And hopefully if you see a problem like this again, you won't have an issue. But if you set it up this way and you're analyzing with this formula, then it's just a matter of putting 1, as it says here, putting 1 in for C. And so, and we're going between 0 and 3. So B is 0 and A is, I'm sorry, B is 3 and A is 0. So we put f prime of 3, f prime of 0, 3 minus 0, and we just take these values right off the table. F prime of 3 is 4, f prime of 0 is -1, 3 minus 0, and we end up with 5/3. So f double prime of 1 is 5/3. All right, you would get 1 point for the difference quotient shown here, and if you skipped this and didn't show that, you could still get that point by showing this. All right. But if you don't show at least the difference quotient here, if all you give is an answer, you would get no credit at all. They would call that a bald answer. All right. You have to illustrate a difference quotient with correct values in order to get both points here. All right. Any questions on that?
Wait, can you use the mean value theorem to prove like more than just f double prime of 1? Can you do any range in that, any value in that range?
You can, but the problem is that you have to have the f prime values. You have to know what, so if you wanted to go from, let's say, 1 to 3.5, you couldn't do it because you don't have f prime of 1. We don't have f prime of 1. We don't have f prime of 3.5, right? So technically, yes, but we don't have those values. But if they wanted to go from 2 to 3 instead of from 0 to 3, or if they wanted to go from 2 to 5 instead of from 0 to 3, we could do that.
Okay.
All right. Moving on. B. So B says use a right Riemann sum with 3 subintervals, so 3 rectangles, to find an approximation for this integral. Again, this table is f prime, so the integral of that would be the area under the f prime curve is equal to f, right? This would be equal to, let me go with a different color here. The integral of f prime is equal to f of 5 minus f of 0, according to the fundamental theorem of calculus. The integral of a derivative is equal to the original function evaluated at the upper bound minus the original function evaluated at the lower bound. All right, so it's the area under the curve of f prime. So to approximate, I've called it r sub 3. You don't have to use this notation. You don't have to write this. But here is essentially the formula for this Riemann sum. The width is 2 from 0. We're going from 0 to 5, and we're using right rectangles. I got to blow this up so we can see the table at the same time. Then this first interval here, this first interval has a width of 2 from 0 to 2 on the x-axis. And I'm doing right approximations, which means I'm using these 3, the right endpoints, those 3 f prime values, those 3 y values. I'm speaking about this generally. If you are totally lost in this concept, then probably the best way to think about this is to draw a graph, to draw the points. If you are so lost that you have no idea what's going on right now, then maybe start out by saying, all right, x, f prime of x, and start plotting points here. When x is -1, f prime is 0. When x is 0, f prime is -1. When x is 2, f prime is +1. When x is, I'm going to run out of space, but that's okay. When x is 3, f prime is up at 4. And when x is 5, f prime is all the way up here at 7. So if I want a right endpoint approximation, I'm using rectangles that look like this. I don't know what it is, but I know it goes through those points that I just drew in black. And the right endpoint approximations would use the x-coordinate of 2, the x-coordinate of 3, and the x-coordinate of 5. Does that make sense to everybody?
I have a question.
Go ahead.
So I was a bit confused. Do the widths, like I didn't know if we could just use those.
The widths are not uniform. The widths are we got a width of 2 for the first one, a width of 1 for the second one, and a width of 2 again for the third one.
Yeah. Is
So
that
this
allowed?
area is 2 times a height of 1. And
Yeah.
then this area is 1 times a height of 4. And then this area is, again, a width of 2 times a height of 7. So
Yeah.
literally have to calculate those 3 heights. Now, again, drawing a graph, I think, is excessive. If you understand right endpoint approximation, then you know you're going to leave out the first value and you're going to use the last value. So everything leading up to the last value. You know you're going to use those, leaving out the first one and going all the way up through this one here, the 7. The key here and the tricky part is making sure that you're careful to pay attention to those widths. Have I answered your question?
Yeah. So, well, my question was, you can do it without the widths being uniform, because I was looking back at my notes
Absolutely.
to try and
Absolutely.
figure it out,
Yeah,
and it said that it
example
had to be
notes,
delta
talked
x.
we talked about, I think, a rocket or something going off into space, and we only had velocity values at differing time intervals. We had a velocity value at like 1 second, and then 3 seconds, and then 3.5 seconds, and then something like that. And we found the area under that to try to find the position or how far that rocket has traveled. You definitely can do this if you don't have uniform intervals. That's fine.
Okay. Gotcha.
So that's what's happening here. The width is 2, and the y value f prime of 2 was 1. The width was 1, and the y value f prime of 3, right? F prime of 3, the y value was 4. The width was 2, and the y value was 7. F prime of 5 was 7. So you get 20. And then finally, we know this is an overestimate because the function is increasing the whole time. So if it's increasing, let's say we have the curve actually going through here, something like that, you can see that our rectangles are outside the curve. But basically, because the curve is increasing and it's a right endpoint approximation, it has to be an overestimate. If it was increasing and it was a left, then it would be an underestimate. All right. 1 point for the Riemann sum, 1 point for the actual approximation. You do not have to simplify down to 20. You could just left it like this. You cannot get the approximation point if you just leave it like this. You can't leave function notation. You have to actually put the number in for each of these values. All right, but you could leave it here. You don't have to simplify that to 20. But if you do simplify it, you have to simplify it correctly to 20. If you put 21, you're going to miss that point. All right, and then finally 1 point for the overestimate with reason. If you didn't have a reason, if you just said overestimate, you don't get that third point. Questions there at all?
Why do you only calculate it in the positive section?
Because if I started with a rectangle being drawn from this point here, that would be on the left side. And I'm using a right endpoint approximation. So to get 3 rectangles, my first point has to be here at 2. There's the height calculated on the right side of the rectangle. My second point here at 3, again, the height of this rectangle is calculated on the right side of the rectangle. And then here at 5, on the right side of the rectangle. If I drew a rectangle here, then I would be using the left point. So there is no negative value here.
Wait, so you're not even supposed to use that point in general?
Not at all.
Oh,
I was doing a left endpoint approximation. I was doing, instead of right, if I was using a left Riemann sum, then I would use -1, 1, and 4, and I would leave this point out.
oh. Okay. Yeah, I see that.
All right. They repeat the question so that you don't have to go back and turn the page over and over and over. The function, I'm sorry, part C, it says evaluate, and they gave us a pretty wonky or weird looking integral here. The integral of f double prime is equal to what? Anyway, the area under the f double prime curve, the integral of f double prime equals what? Anybody?
Well,
I
it says
got
there
4.
1/2 f prime of 5 minus
Not
f
4.
I'm just speaking in general. In general, I don't want an answer to this question, to this particular problem. I want just generally speaking, if the area under f prime, is f, then what is the area under f double prime?
F prime.
There we go. So the integral of f double prime is f prime. Sorry, I'll do it lowercase. Plus c. All right. The antiderivative of f double prime is f prime. And if you interpret that in terms of area, then we're talking about literally the area under the curve. But this one, we don't have to talk about it, I guess. Yeah, we do, because we've got a definite integral. We do have to discuss it in terms of area. So this problem is asking you to basically use these function values. If I was a little bit more specific here, I could say from A to B, and then this would be the area under the second derivative curve from A to B would be f prime of B minus f prime of A, fundamental theorem of calculus. So I need to calculate the antiderivative, evaluate that antiderivative at B, and then evaluate it at A. Problem is, I have this extra stuff, 2x plus 1 going on. So I do a u substitution. Let u equal the stuff inside, 2x minus 1. du is 2 dx. And if I have this 2, then I'm going to have this 1/2 out in front. I went ahead and changed the limits of integration as well. So if I define u as 2x minus 1, then u of 2 must be 3. If I put 2 into this, I get 3. If I put 3 into this, I get 5. So now my limits of integration are 3 and 5 instead of 2 and 3. And I never have to go back to x. So with this u substitution, now it's f double prime of u inside the integral and du, and I multiplied by 1/2 because that du put an extra factor of 2 right there. All right, so are we good up until this point right here?
Yes.
Yes.
All right, so then the antiderivative, as the fundamental theorem of calculus up here suggests, is f prime of the upper bound 5 minus f prime of the lower bound 3. All right, so 1/2 times all of that, that 1/2 is just chilling out there. And of course, f prime of 5 and f prime of 3 are taken directly off the table. They are 7 and 4. And so my final answer is 3/2. 1 point for the antiderivative. 1 point for the fundamental theorem of calculus being demonstrated, and 1 point for your actual answer. This was right off the rubric. So when I look at this and I say 1 point for antiderivative, I'm a little confused. Maybe they're saying 1 point for demonstrating at all that you recognize that the antiderivative of f double prime is f prime. So even if you had some sort of error anywhere where you left off a value and maybe you didn't include the f prime of 3 or something like that, as long as you recognize and show in your work that you see that the antiderivative of f double prime is f prime, which is what I discussed at the very start of the problem, then you're going to get that point. Fundamental theorem of calculus, you would have to show the subtraction of these two values. And then the answer would be, again, you don't have to go to 3/2. You could have left it like this. Could have left it as 1/2 7 minus 4. All right. Tricky for sure, because they make this 2x minus 1 substitution in here, which means you have to do a u substitution to change it. Questions at all on this problem? All right, I bet we have time for D, and then that's about it for this class. Unless anybody wants to stay on, I can keep going, and I'll just keep the recording going. All right, D I found to be probably the trickiest of all of the problems. Not going to lie, this one had a lot going on. It was all of this notation that was just ugly. Let's get our heads back into it. Look at the stem of this problem. It says, we know, we're told here, it is known that the limit of this ugliness can be evaluated using L'Hopital's rule. Stop right there. What does that mean? If this limit can be found using L'Hopital's rule, somebody muted me. Anyone?
That it's either 0 over 0 or infinity over infinity.
Very good. So that means if you were to put 0 directly in, the top would be 0, the bottom would be 0. So with that information, that's where I'm going with this here. If L'Hopital's rule works, then it must be true that the limit of the numerator equals 0. Which means if I put 0, we evaluate limits by doing direct substitution. If I put 0 directly in for x, this should equal 0. So why is this important? Because it's going to help me find f double prime of 0. I have no information about this point. So if I set that numerator equal to 0 and plug 0 in for the x values, then I find, f of 0 right off of the original information. They told us f of 0 was 3. This is where we're calling back. I go back up. This is where we're calling back on that information. F of 0 equals 3. This is the first time we used that in this problem. They told us f of 0 was 3. So my screen just locked. Let me bring it back up. Hold on. There we go. They told us f of 0 was 3. And so that's where I'm plugging that in here. And 2 times 3 is 6. And so e to the 6 minus 6 is e to the 0, which is 1. E to the 0 is 1. So 4 times 1 just leaves me with 4 for this term right here. The e just goes away. And then f double prime of 0 equals 0, which means 4 minus f double prime of 0 equals 0. That means f double prime of 0 must be 4. Now that I have that, I can try to apply L'Hopital's rule to solve this limit. Without this information, you're dead in the water. All right. So now I'm going back to the limit. Before I do that, though, let's see. And in this column here, does anybody have a question on what I did over here? We're all good? Okay. So now by L'Hopital's rule, in order to apply L'Hopital's rule, I would do the derivative of the top divided by the derivative of the bottom. And so that's what I've got here. The derivative of the top over the derivative of the bottom. So the derivative of the top, gotta be careful here. This 4 is just chilling. I didn't show all the work, and so that's why deciphering this term right here is not quite as easy as I think. Probably not quite as easy as for you all. The derivative of this is 4 times this e function is just repeated. The derivative of any exponential is the original exponential times the derivative of the exponent. So the derivative of 6 minus 2 f of x, the 6 goes away, but I still have negative 2, and then f prime of x, the derivative of this. And so that's why the 4 became negative 8, because 4 times negative 2 is negative 8. And then I have this f prime sitting out here. So again, the derivative of this is all of this. All right. And then the derivative of f double prime x squared is this. 2x f triple prime of x squared. The derivative of f double prime is f triple prime, but the chain rule says I have to multiply by the derivative of the x squared, which is this extra 2x. Again, I am going to say it one more time. I thought this was probably the hardest problem on the entire test. And this part here was probably going to be the most difficult for you. And then the bottom is the easy part. The derivative of f prime of x plus 1 is just f double prime. The 1 goes away, and the derivative of f prime is f double prime. All right. So I've tried to demonstrate here with the colors. The derivative of that red piece is here in red. The derivative of this blue piece is here in blue, and the derivative of this orange piece is here in orange. Questions there?
Could you just leave it as 8 over f double prime of 0? Or
Yeah.
do you have to-
In other words, do you have to show any of this?
Do you have to show the f double prime?
No, I wouldn't think you do. If you can see by looking at this that all is just 8, I don't know how you would do that, but clearly here, the E is going to go away again. But I mean, I don't know how you would get just straight to 8. I think you at least have to show that you're multiplying this -8 by f prime of 0. And by the way, f prime of 0 is -1 right off of the table. You go back to the table to find f prime of 0. And then, of course, e to the 0 again, which is 1. And this is all multiplied by 0, so this just all goes away. I would think you could leave this off because you're multiplying by 0, but you probably have to have a step in between to show this.
Oh, okay. Wait, no, but for the final answer, could you leave the final answer as 8?
Oh, yeah. Absolutely. Final answer does not have to be 2. The final answer you could say is just 8 over 4, or really you could leave it like this, because all of that is numerical. You do not have to simplify that.
But you have to find f double prime of 0. You can't just leave it as 8 over f double prime of 0.
Correct. You cannot leave this. You have to plug in for function types. The answer must be numerical.
Okay.
Right here, this is functional. This is not numerical. All right, and then the breakdown of the points. This was a 4-point problem. It was a tough one, and so it was worth more points. First point is setting the numerator equal to 0, or finding. If you didn't show all of that work, you could still get credit for saying that maybe you did it off on scratch work, that f double prime of 0 equals 4. There's only one way to find this, and that is by setting the numerator equal to 0 and plugging 0 in for x. So if you had somewhere that f double prime of 0 equals 4, then they're going to trust that they would trust that you knew what you were doing to get it, because this is the only strategy. Then 1 point for using L'Hopital's rule. Showing that you're attempting. What they would say here, since you're taking the derivative in 3 places, is they would say 1 mistake is acceptable to get the L'Hopital's rule, 2 mistakes, and you miss this point also, because the derivative is a separate point. So all 3 derivatives have to be correct to get the derivative point. But if you have 1 mistake in a derivative, you can still get the L'Hopital's rule point. And then finally, the answer is a point. So that's a 2/3 rule, we call that. If there are 3 points, 3 places where you're doing the same thing, if you get 2/3 of it right, we'll give you the preliminary point, but we won't give you the other point. All right. I'm probably getting into the weeds too much about how this is graded, but all right. We've gone 2 minutes over. We're out of time. Anybody wants to stay on, I can keep going, or I can stop this video and start a new recording. If you have somewhere else to go, like chapel, and you're dying to go to it, you can sign off in just a moment. Let me wrap up by saying, again, I seriously hope that some of you all will reach out to me and go over some of this work, the practice exams that were discussed in the videos, or any of these problems like this that we have done together. Please reach out to me, and let's make sure that you're well prepared. You guys have worked too hard to come this far and not put forth a strong effort on this test. The Khan Academy stuff, some of you have dropped the ball seriously on that. Please go back and use that as a review and practice and finish that stuff up within the next 2 days. And use those videos as your final resource. Finally, it has been a pleasure. I wish that I had a chance to shake all of your hands in person and say congratulations for a successful year of AP Calculus. But unfortunately, we're not able to do that. Just know that I have felt honored to teach every single one of you, and I am confident. I strongly believe that all of you, every single person in this class, is capable. I did not feel that way last year, but everybody in this class is capable of passing that exam with a 3 or higher, and I am proud to say that. That's it, I guess. Just know that it has been my honor, and hopefully you won't forget your AP Calculus class for many years. If I don't talk to you again before the exam, good luck. Do your best, relax, and have fun learning some math and showing what you know. All right? You guys can sign off if you want. If not, I'll stay on. Anybody want to stay on and keep going with this?
I have a question.
Okay.
Where is this going to be posted? Like the video?
It's going to post in the team chat, in the Teams. It'll post right there, but also I will link it to a YouTube video and put it on the portal.
Okay, great.
Thank you.
Thank you. It was a good
Well,
year.
we'll see y'all.
Thank you, Mr. Heineman.
Bye.
Thank
Thanks.
you.
Bye.
Thank you.
Thank you.
Schaefer, happy birthday.
Oh, happy birthday, Schaefer. Yeah, I think you already signed off. Yeah.